Exercise related to alternative to practical questions. We'll do a question first with this from this exercise related to planning experiment, and then we'll move on to the moles questions. Okay. Okay. If you want to plan this experiment, we have a magnesium react with a dilute sulfuric acid at room temperature to form a hydrogen gas. Plan an experiment to find the rate of a reaction between a magnesium ribbon and the dilute sulfuric acid. So magnesium react with the sulfuric acid to give off hydrogen gas, and we want to investigate how the rate of the reaction changes or varies, or we want to investigate or find the rate of a reaction. In your answer, include the diagram and indicate how you could use the results to obtain the rate of the reaction. You are provided with a common lab apparatus, a magnesium ribbon, and a dilute sulfuric acid. So if we have first what apparatus, because we know hydrogen gas is given off and we want to measure the rate of a reaction whenever there's a gas is given off. So we can measure the volume of a gas given off, or we can measure the change in the mass as we allow the gas to escape. So one way of measuring a rate, we'll have a conical flask which will fill with a known volume of a sulfuric acid. We connect a gas syringe and record the volume of the gas in a unit time, and we'll get the rate of this reaction.
There's that test tube inside the conical flask and
yeah.
So the gas doesn't escape.
Good.
For more
accuracy. More accuracy. The second way of doing it, we allow the gas to escape. So we'll place a cotton wool and we add a magnesium ribbon to a sulfuric acid. The hydrogen gas is given off, which will escape. So what will happen? The mass of the content in the flask will decrease. So these are the two ways by which we can measure the rate or the speed of this reaction. So how to plan this? First, we let's say take 10 cm cube of sulfuric acid in conical flask. Then we will add measured mass of magnesium ribbon or a size. Even magnesium ribbon, you can compare the size as well. So measured length of a magnesium ribbon. Then connect the gas syringe. Yeah. Then start the timer. And record the volume of the gas. Every 30 seconds for, let's say, 5 minutes. Then find the rate by using a formula, change in a volume divided by time interval.
When you get marking, you said if the volume
and the marking reference points, what are marking reference points? Like the things you can list, you can see here. That's how the marks are distributed. If you mention, like when we are measuring a volume of a gas, first thing you mention a magnesium as added to a sulfuric acid, that will score 1 mark. Suitable container, ability to have a bung, like example we mentioned in a conical flask, we'll score that mark. Measuring a volume of a gas, so we connect a gas syringe, or we can also use a displacement of a downward displacement of a water using a measuring cylinder. Then we start the timer, then measure a volume of a gas, and at set time or at the end of experiment or regular interval we mention, and the rate is volume divided by volume divided by time. These are the points. What is the meaning of the downward displacement? Like if you have a conical flask, you connect and you are collecting the gas, and this flask was filled with a liquid, the water is there. So what is the meaning of the term downward displacement? When the gas is given off, gas will rise up, so the water will be displaced down. So that is meaning of a downward displacement of a water. Like a container is there inverted and filled with the water, not fully, but as the gas is released, the water will be pushed out from it. The gas here is a hydrogen gas. The downward displacement method means, see, you have a conical flask. One way of collecting the volume of the gas is we can directly connect the gas syringe and we collect the volume of the gas. That is one way of doing it at a certain time interval. What is the second way of collecting the volume of the gas? The gas can also be collected over the water. If the gas is insoluble, then we prefer this method. The main reason of preferring this method, because when the gas is given off, so we can see the bubbles are forming. So you have a delivery tube is there. This is placed on the water and you have a container here. And in container is also having a water. So what will happen when this hydrogen gas or a gas is given off? So this gas will goes up and the water will move out. That is called a downward displacement of the water. Example of insoluble gases, like example, hydrogen is insoluble in water. Sulfur, such as nitrogen dioxide, nitrogen is also insoluble. Proportion is same thing. Organic, like example, methane is also insoluble. So the main idea is that how we can collect the gas. Is it clear, this experiment?